Okay. Hi everyone. My name is Thakon Tangphati. Today I'm going to teach you about the liquid in subject basic medical physics. Uh, Before I start, I would like to put everyone on the same page. Uh, this is the first class that I teach you, and this is the next step from Dr. Navi. Um, the rule for my part is a little bit different. So you can make some scores in my part from the WU e-learning. So you can learn about this by attending this class or studying by yourself. And after that, you have to do the quiz in the e-learning. So all of the score will be split into two parts. The first one is the quiz, and the second one is in the final exam. That's it. So if you are busy or you already understand it, you don't have to attend my class. That's it. So I give you freedom to choose. But the benefit to attend my class is that you would know the hint for the final exam. Mhm. And you can enjoy the class. Okay, if you have any question, you can ask me directly. Uh, you can contact us from in, in the class or maybe from the Facebook. Mhm. So I would like to start this class. Mhm. Okay, I guess everyone will see this one. Okay, the first one. You can download this PowerPoint slide via the WU e-learning. Okay, so don't forget to do your quiz because all of the score, excluding the final exam, would be in the quiz. Okay, you can do the quiz as much as you can. I mean, if you did not get the full score, you would repeat it. You can come back to do it uh, as many times as you can. So every time you click to do the quiz, the system will generate the random questions to you. So uh, as many as you can go in to make the quiz, so you can get a lot of questions. You can learn more. So no matter how much score you have, you will get the highest score that you try to do. So it would be easy for you to study because sometimes you might get bored in the class, but you might want to study by yourself. You might want to go to the e-learning, and that is it. I give you that uh, option. So don't forget, okay? You attend the class and then you take the quiz outside so to make sure that you get the uh, score that you want. Okay, for this for this time, for the first time, um, liquid and blood circulation would be the lesson for today. Okay, the objectives for this one is that the first one, uh, I would like to lecture about this because I would like everyone to understand the basic laws about the static and flowing liquids. Okay. And the second one is about the mechanism of the blood circulation and other liquids in human body. So it's like the application of the liquid and the idea of of this to the human body. So, what is liquid? Mm. So, you guys know about liquids. In Thai, we call it ของเหลว เนาะ So, what is liquid? Liquid. Uh, you may know some examples. For example, water, oil, blood, mercury, milk, something like this. So, liquid is a state of matter with a definite volume, but 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 no fixed shape, which means that you have to find a container to contain it, and the shape of liquid will change due to the container that you have. Okay. In human body, uh, there may be two types of liquids in human body. The first one is the liquid at rest in human body. So we could use the term hydrostatic to describe it because hydro means water and static is like a stay still, like a stop, pause, mhm, something that doesn't move, that is static. So the example of this type of liquid in human body, for example, cerebral spinal fluid, aqueous humor in the eyes, and for example, urine. Uh-huh. Uh, the next type is about the liquid that can flow. Uh, we can describe uh, it by fluid dynamics. Okay? For example, blood and sweat. In men and women, there is different amount of liquid in our bodies. Uh, for men, we slightly have higher percentage of liquid than women. Do you know why? hmm Do you know why? Okay, just think about human body as a factory. A factory would need some something to run. For example, uh, electricity or uh, the circulation. The human body, especially in male, in male, there is a lot of muscle, so we need more food, right? More energy. So the total body water in men would be a lot higher because the system need to serve that muscle. Higher muscle, higher needs for blood, oxygen, and it also produce a lot of carbon dioxide. So we need to release this outside the body. Okay. Uh, there are two types of liquids. Uh-huh. Uh, hydrostatic and fluid dynamics. Okay. So liquid is like a subset in a fluid. Okay. Fluids may be split into three branches. One is liquid, another one is gas, which will be teach in the next class, and then plasma. So plasma is not plasma in the medical terms. Plasma in this case means another state of matter. When you, uh, uh, for example, when you put a lot of energy of high temperature into some gas, the gas will ionize. So you can get the positive and negative charge. The positive charge would be ion, and the negative charge would be electron. Mhm. That kind of the state, which is at the very high temperature, uh, for example, at the corona, which is the outside shell of the of our sun. Okay. Okay. Right now, we study about the hydrostatic pressure, which I am sure that you guys understand about this from the high school. Okay. By the definition of the pressure, it is the ratio between force and unit area. Okay. Pressure equal to force by area. And the unit of the pressure can be Newton per square meter, or maybe Pascal, or maybe ATM. ATM is the abbreviation from atmospheric, and maybe tall or millimeters of mercury. Uh, at the sea level, the atmospheric pressure is 1 atm. That is the atmospheric pressure at 1 atm. So at 1 atm, you can convert into other units. For example, it is about 760 millimeter of mercury, or we can call it 760 tall. And when you convert it into the metric unit, Newton per meter square, it's, a, it's around 10 to 5 Newton per meter square. Or we call it Pascal. Mm. So the pressure due to the static liquid. So as I mentioned that the liquid must must be contained in a container. So in this case, I consider a cube. Okay, there is a liquid into it, and here liquid, and the here gas is air. To understand about the pressure of this liquid that push on the floor, we use this one, the definition that already mentioned. So the force that act on the bottom due to the mass is empty. Okay, and there is an area. Uh-huh. I assume that the area on the top and on the bottom is the same. So we can use this one. A is the area. And right now, I can use the identity, which is the ratio of H by H. Okay. And then we just combine it. A is the area and H is the height. When the area multiply, oh, sorry, when the area multiple H, it would become volume. Volume integral Parima. Mhm. And then we just make it into this one. The ratio of the mass and the volume become density. So rho is a density. of liquid. Okay, so I just showed the derivation that you already learned in high school. Uh-huh. And this one, we call it gauge pressure. Mhm. So gauge pressure is just only the pressure of water or liquid on the bottom of the container. However, when you ask about what is the real pressure on the container, we call it absolute pressure right here because we have to add another one, which is the air pressure. So the gauge pressure is just only the pressure from here, from the liquid, right? But there will be the air on the top that already pressed on the liquid, mhm, and the liquid press on the floor or the ground or the bottom of the container. So we need two things. Mhm. It's up to you that you would like to understand which one. If you would like to understand just only the pressure of the atmosphere, you answer to the air pressure. If you want to know just only the effect of the liquid on the floor, this one, it's okay. Just gauge pressure. But if you want to calculate all the effect, you have to understand all. So here, absolute pressure. Next, we can apply the idea of the total pressure that can combine from the uh, air pressure and then the gauge pressure to invent the measurement of the pressure. So in these pictures, they use the same technique, but just in different form. For example, on the left-hand side is a manometer. The manometer, they will contain the pressure that you already know. We call it reference pressure. It's like that they already calculate and calibrate it. So we know exactly the value of the reference pressure. And then you add some liquid right here. Mhm. When this manometer contact to other objects and it give you pressure here. So this pressure will press the liquid, okay? And then the height change here, delta H, will tell us about the pressure, the total pressure. But you can see that in the manometer, the press, the the pressure, sorry, in the manometer, the device that look like this is not easy to handle, right? Because the U-tube and the pressure inside, and you have to measure about the height here. Okay, might not be easy. So another one here is the burden gauge. Ah, the burden gauge, you can see that there is a gauge in the circle. Actually, inside it, there will be a tube like this, something like this. Mhm. The the pressure outside come here and push the liquid around here, where the reference pressure would leave here. Okay. Uh, as I already write in this picture, it's about uh, when the gauge is not contact to the source. But when it contact to the source, it would change shoop, to here. Uh-huh. That is how the Bourdon gauge works because the pressure and press the pressure to be compressed. Mhm. So they can make the case for you to understand that the outside pressure uh, is at uh, what level. So I would like you to see about how to calculate for the manometer. Here it is keyword. It's very important. The pressure of liquid at the same level that already linked will be equal. For example, here, I would like you to focus on here. Here is the liquid, okay? When this system, when this gas contact to the pressure source, right? The press, the pressure, the pressure outside will push the level of the liquid. So you can see the difference of the level of the height level right here. Shoop, shoop. Mm-hmm. So because the liquid is connected, so the PA, which means the pressure right here at A, equal to the pressure at point D, which is in the different side. Okay, so you can set that equation. Okay, and think as I mentioned before, the pressure at point D would be equal to the total pressure that's already pressed up, that's already pressed on on the point D. So if you consider point D, there would be two factors that already pressed on point D. The first one here is the gauge pressure. The second one is here. It's a reference pressure. So PC P at the surface is plus by the reference pressure, and the gauge pressure is here. Mm. That would be 1 and 2. So the reference pressure can be calibrated. Uh-huh. So we know exactly what it is. And then you just calculate only just the height difference delta H here. You can find the density of this liquid here. And you know the G is around 9.8 meters per 6 square. Mhm. Just it. Then, if you would like to know the pressure outside, you can calculate from this equation. That is it. So here is just an example of the effect of hydrostatic pressure. In this case, for example, there is a man standing here. Shoop, shoop. Okay. And his heart just above his feet, 1.3 meters. Mhm. So if you neglect the blood flow, just only the static liquid, okay? If you would like to understand to calculate the pressure difference, pressure difference, I P here about heart, and P here is about feet. Okay. The pressure difference means PF minus PH. I use this one because I already know that the pressure of the foot is higher than the heart because foot is lower than heart. Okay, but he is standing. Okay, so just the gauge pressure, just it, gauge pressure, and here the rho, which means the density of blood, is around 1.5 10 to 3 kilogram per cubic meter. G is around 9.8, and the height difference is 1.3. When you do something like this, I recommend you to add the unit. Okay, for example, you might write the number and then write the unit. After it, unit of this one, and then unit of this one, and here, last one. You will see that you can change the unit of this into kilogram. Sec square, which is the unit of pressure. So you can get the unit of Pascal. To change from Pascal into torr, you can use this equation. You can use this equation. For example, if you get in Pascal and you would like to change from Pascal into torr, you just set the unit that you want and unit that you would like to get rid of. Okay, something like this. And you try to use the identity. For example, the relation between the unit torr and Pascal is here. So 160 and 1.01 10 to 5, something like this. So the unit will be get rid of and leave just only torr. The rest is about the calculator. So you just input the number of the x and that's it. The rest is about the calculator. Okay. And the effect of the hydrostatic pressure, uh, we already know that by average, the head is about 0.45 meters above the ground. So the pressure difference is about 35 Thor, which is lower than the pressure difference between your feet and your heart. Then, if human is laying down or sleeping, the hydrostatic pressure at heart, feet, and head will be equal. Mhm. The volume of blood vessel in the head is slightly reduced because the pressure change. Okay. For example, when someone is waking up and he or she tries to stand immediately, it might cause a little bit uh, numb because the rapid change of the pressure. So when you take care of elderly, you have to be careful about their movement because it might change the pressure a lot in every body. And another one is about the Pascal principle. The it's about uh, the system of the pressure change. Uh-huh. In this case, I would like to assume the incompressible fluid. Incompressible means that even you put or pull the container or you exert the forces into the system, the volume of fluid would be the same. Mhm. Not bigger, not smarter, but the fluid will try to find a way to leak, but it doesn't. But it's not gonna be bigger or smaller. Okay, it tries to transmit to anywhere to to fulfill the volume. Okay, and why we have to uh, study about this? Uh, I would like you to see the picture on the left hand side. You might see that it is the hydrostatic pump, which mean it there is another called hydraulic pump. Mhm. Uh, it, this is a very amazing tool because you can lift uh, the heavy things like cars, trucks by your own hand. So let's see how it happens. For this case, I would like to neglect, omit the pressure change from gauge pressure. So right now, we assume there is no gauge pressure. Okay, pressure. Rho equal, sorry, P equal to rho GH. No, why? How could we neglect this one? We just assume that H is small. So P, I mean delta P would be zero. Okay? Delta P would be zero. Okay, for this one, you know that at the same level of pressure, sorry, at the same level of liquid, the pressure would be the same right here. Mhm. So we can get that at 1 and 2, the pressure is same. So P1 equals P2. And with the definition of the pressure, it is the ratio of the force and area. Okay. You can come by each other here. You finally get this one. So what does this mean? So this means that if you would like to lift something very heavy, you just put that heavy things in the large area, the large surface, because the force will be spread in very large area. And all you have to do is just to push or pull at very small area. So you will get the effective. For example, if you are at near the area 1, you have to exert your force F1, right? Which is F2 and A1 by A2 here. If A2 is larger than A1, So you will get F1 will be less than F2. Okay. If the truck is about 100 tons, you don't have to find uh the weight, the mass tons to lift it. You might find just something just like your hand. It depends on the difference of the area. Mhm. If you can make it difference, for example, if A1 if A1 is 100 times smaller than A2, then you just need only 1 ton to lift the 100 ton. Okay. And I will talk about it more in the exercise, in the active learning activities. The application of the Pascal principle right here. Do you know the water bed? Water bed. Okay. The water bed can reduce the stress on your back when you sleep, when you lie down. Just see, for example, if you lie down on a solid floor, you could see that the pressure act to you in different point, right? So these 5 points will get the pressure a lot, while the others might not. Okay. However, if you lie down on the water bed, 3 point contact to the water bed. Mhm. It would bear uh, it would bear your weight equally because the water bed try to shape it into your shape of your body, especially when you lie down. So you might not get uh, the backlash. It would save you from the injury. Mhm. And inside the eye, there is a lot of fluid in it. I mean, liquid. Because when you touch your eyes will ex expand. Sorry. When you touch your eye, the pressure will be increased, and it will spread the pressure all over. So there is no exact point get the whole pressure because it's already spread out. Then, for example, when you touch your eye around here, the force would not go directly to your optic nerves. However, it's spread all around. It's spread all around. So it might not cause a lot of damage to the optic nerve. That's it. Another one is about fetus. The reason that there would be the surrounding fluid in the fetus because when the fetus of baby try to move, the stomach of the pregnant woman would not be explode. Okay, for example, if uh, the fetus shake or move or touch, the pressure of the fluid would carry that pressure all over the surface, not just point to the exact or just one point. Mhm. Another one is about the urinary bladder. Here, when the urine is contained in the bladder, the level increase, 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 increase. When it when the bladder contains the urine at some level here, the pressure here you can calculate from the gauge pressure P equal to rho GH. It would be higher as a function of the height. Okay, the higher level of the urine, the higher gauge pressure, and you would feel that you have to pee. That's it. Mhm. And this one is another example for uh, a baby that got a disease when the cerebral spinal fluid that uh, is blocked. So you can see that here, some part of a brain block the liquid flow that it caused the fluid into head, and this caused the disease, which the baby will get bigger and bigger head. Another one is about the buoyancy force. uh, this one is very important for the application for the today for the today technology. Uh, Archimedes discovered it. As you can see, uh, for this picture, a mass with around 7 pounds, 7 pounds, 7 pounds. And when you put it into water, the weight is around 4 pounds. Why? Mm, that is very frustrating for the first time that we understand. Because when you try to weigh the mass, try to measure the mass in the air, you have to lift it up. For example, here, G, shoop, shoop, this tension. You have to lift it directly, so there is no assistance. However, when you put into water, the water will have the buoyancy effect that would decrease because there is another force here, buoyancy force. Mhm. So for this one, if the system is whole in is whole without acceleration, T minus mg equal to 0. So you can get T equal mg, which is 4 pounds. And another one, if you hold it very still, T prime minus mg plus fb equal to 0. I put fb with plus because the direction of the buoyancy force is upward. So it will be plus sign. And when you calculate it, the weight that you get is slightly changed. It's lower at 4 pounds here. So the application of buoyancy force is about, for example, the floating water in sorry, uh, floating in water. So the buoyancy, the buoyancy will reduce the weight that carried by muscle and bones. And this therapy would help some injure patient. Sometimes they cannot walk, they cannot run. They have to lie down on the bed. But if they lie down all the time, from weeks to months to years, they will lose the muscle. So to gain the muscle, they might have to walk a little bit in the water, which has the buoyancy force to help uh, to help uh, the exercise, so they can gain mass, the muscle, uh, easily. And another one is about the hydrotherapy. Uh, Sometimes, not just only the exercise in the water, but uh, they have to control the temperature inside their body. So the the therapist might put the patient into this tub, and they fill in with water, so they can change the temperature into the suitable one. Mhm. As you can see that when they sit here, the pressure will act to at least 4 points. Not just only that, but there will be a buoyancy force. So their body would not have to hold their weight alone, but the buoyancy force will help. Another one is about hydrodynamics. Right now, we are moving from the uh, hydrostatic into fluid dynamics. Okay, they can move, and we still have to apply the incom sorry incompressible fluid and well. Okay, in this case, you can see on the right hand side, sorry, on the left hand side, if this pressure is put, yeah, this volume here will be pushed from here, and it will act right here. So I assume that here is the volume V1, and right here we call it V2. If we apply the incompressible fluid, V1 must be equal to V2. Okay, and you can change it. You can, you can generalize it. So volume can be right into area multiply height. Mhm. So here is h. In this case, they use x1. So right here is the volume change in the first zone, and right here is the volume change in the second zone. You could see that here is the volume reduction in the first area. And here is the volume, I mean all here, increase in the second area. Uh-huh. The volume is reduced in one place and it will be increased into another one. That is why we have to apply the incompressible fluid. And here is the Bernoulli equation. There will be three terms. The first one is the volume. So sorry, original pressure at that place. If you consider this one, so this is P1. And then this one look like the kinetic term. This represents the speed of the fluid. Mhm. And here, rho g h is the potential one. Wait, sorry. If you compare to the uh, energy law, the kinetic energy is the half mass v squared, right? And the potential from gravity is the m, g, and h. You just change from mass into density. Uh-huh. And you get this. Okay. Because when you consider the Bernoulli equation, you try to understand the dynamics of fluid in two areas. So there must be the area one, right? This one, this one, this one. And the second area, this one, this one, this one. All remain the same pattern. The original pressure, the kinetic terms, the potential terms here. And you can study in other places, for example, right, as well. So it would be P3 plus here, here, something like this. Mhm. So this can be applied into the water aspirator. So, for example, uh, you have the yeah, the subject that you want to reduce the pressure. So how to reduce it? You have to get the pressure out of this container, right? So how to do it? All you have to do is to connect it into the tube that the the input have large area and the output have the low area. Right here, this system will be the pressure of the system will be sucked out of it. However, if you do it inward, for example, you would like to add the pressure, you can do it inwards. For example, here is your container, right? And here, just put here. shoop, shoop, something like this. You can do it inversely, but it might not be efficient. That there may be another way to add the pressure, but it can do it this way. Another one is about the viscosity. I would leave this into your study. I would not add this into the final exam. So you can read the rest of this. Another one that I would like to teach before I move to the uh, before I move to the active learning. So we have to solve some problems. Is the capillary action. There is two forces that you have to understand. One is adhesive force, and another one is cohesive force. Adhesive, add is like plus, right? It's like a many things. So yes, adhesive force means the force between two different things. Cohesive force, co. Co is like the same thing, the same team, something like that. So the cohesive force is the force of the same type. For example, water, right here. Water right here. The water has adhesive force more than cohesive force because adhesive force in this case means the force between water and glass. So two things, right? More than cohesive force between force, water and water. That is why when they contact to the glass, the water have higher higher height than the normal level. However, for the mercury, they would like to interact to the same type to to mercury itself. That is why when you put the capillary into mercury, mercury level in the capillary would be lower than normal because it dislike to interact with glass. So you can calculate right here. You can calculate right here. For this case, it's about the effect of adhesive force is stronger than cohesive force. Here is and right here is the tension force. Tension force from the capillary action. Okay, but because right here it's just only the cross section, you have to make it into 3 dimensions. So right here would be 3 dimensions. So there would be T right here, T right here, T right here, T right here. That is the reason why you have to multiply with 2 pi r, where r is the radius right here. And you sorry, and you have to consider the axis right here, t cos theta t, t sine theta. all the force in the uh, all the force in the perpendicular direction would be cancelled out. Okay, leave just only t cos theta. So t cos theta multiply 2 pi r equal to mg right here. And because the mass in this case we can change it into rho v g right here. And we can transform the volume into the tube, which is the cylindrical tube. So finally, you can calculate the height right here. So the height would be 2t cos theta by rho g r, which is the height of the liquid above or below the normal level of that liquid. In case that h is minus, which means that the theta would be greater than 90 degree, for example. Shoop, shoop is normal level right here and here tension. Theta would measure from here to here. And in this case, you will get the height right here less than 0. So in this case, it implies that if the force between cohesive and adhesive force is the same, you could see that in the capillary, that's normal, and here is normal, which means that the tension would point parallel. And in this case, you could see that the theta equal to 90 degree and h equal to 0 because cos of 90 degree is 0 here. Okay, and the rest is for like the further reading. So the blood circulation that I would like to introduce a little bit. Okay. The hearts of human normally beats between 75 to 80 per minute, okay, per minute, and it pumps around 7,000 liters per day. You could see that there are 4 parts of the human heart, and here is some quantities that you would like to remember. For example, systolic pressure. This is the pressure of the blood vessel when the heart beats is around 120 tall. And another one is the diastolic pressure. This is when the heart rests. The pressure is around 80 tall. This is in just only the normal condition. If you sit, not just run. Okay. So the difference between the systolic and diastolic is referred to the pulse. You need pulse to run the blood circulation. So yeah, for the hypertension, uh, for the further study in your field, you would understand this more than me. But I just try to tell about the the basic. Okay, the word hyper mean high, above, exceed, more, something like that. Tension, okay, pressure, high pressure. Mhm. The high the high tension or the hypertension arise from the rhythms in the flow in the blood vessel, which means that there is something that blocked the blood circulation. So the heart try to pump more and more and more and more. For some cases, the blood cannot go to some cells. The cells will die. For example, the brain, mhm, some organ dies. Okay, to provide sufficient blood flow, so the heart needs to raise the pressure. That is the hypertension. Okay, for the regular exercise, so sorry, the hypertension in normal condition can happen. For example, when you do the regular exercise, it will increase the hypertension, but naturally, okay, naturally. That is not dangerous. It it should be, it should be, but the hypertension from the resistance right here, it's not natural. So we should do the exercise because it would increase the pressure naturally. So your temperature in your body increase as well. It would help your body with cold. Also dilatation. Sorry. So your blood will become less viscous. Less viscous, which means that flow efficient efficiently. Mhm. So thank you for your attention today. I mean that uh, today I might be a lot of excited because this is the first time that I teach in English, and I try to do my best to make this video. So I thank you for your attention that try to understand what I said. Thank you, thank you. Next time I would speak better and better. So as right now I am still feel excited. You can leave any comment to the Facebook. You can uh, you can ask questions. You can give them comments. You can ask for anything. And if I can do for you, I will provide. So this is the first part of today class. So the next one is for the exercise. Okay. And I will leave it in another video. Thank you for your kind attention.